Camera resectioning is the process of estimating the parameters of a pinhole camera model approximating the camera that produced a given photograph or video. Usually, the pinhole camera parameters are represented in a 3x4 matrix called the camera matrix. This process is often called camera calibration, but camera calibration can also mean photometric camera calibration. Parameters of camera model, often, were used to represent a 2D point position in pixel coordinates. Is used to represent a 3D point position in world coordinates. Note, they were expressed in augmented notation of homogeneous coordinates, which is the most common notation in robotics and rigid body transforms. Referring to the pinhole camera model, a camera matrix is used to denote a projective mapping from world coordinates to pixel coordinates. Intrinsic parameters equals. The intrinsic matrix contains 5 intrinsic parameters. These parameters encompass focal length, image sensor format, and principal point. The parameters and represent focal length in terms of pixels, where under the scale factors relating pixels to distance and is the focal length in terms of distance. Represents the skew coefficient between the x and the y-axis, and is often 0. And represent the principal point, which would be ideally in the center of the image. Nonlinear intrinsic parameters such as lens distortion are also important, although they cannot be included in the linear camera model described by the intrinsic parameter matrix. Many modern camera calibration algorithms estimate these intrinsic parameters as well. Extrinsic parameters are the extrinsic parameters which denote the coordinate system transformations from 3D world coordinates to 3D camera coordinates. Equivalently, the extrinsic parameters define the position of the camera center and the camera's heading in world coordinates. Is the position of the origin of the world coordinate system expressed in coordinates of the camera-centered coordinate system. Is often mistakenly considered the position of the camera. The position of the camera expressed in world coordinates is. Camera calibration is often used as an early stage in computer vision. When a camera is used, light from the environment is focused on an image plane and captured. This process reduces the dimensions of the data taken in by the camera from 3 to 2. Each pixel on the image plane therefore corresponds to a shaft of light from the original scene. Camera resectioning determines which incoming light is associated with each pixel on the resulting image. In an ideal pinhole camera, a simple projection matrix is enough to do this. With more complex camera systems, errors resulting from misaligned lenses and deformations in their structures can result in more complex distortions in the final image. The camera projection matrix is derived from the intrinsic and extrinsic parameters of the camera, and is often represented by the series of transformations. For example, a matrix of camera intrinsic parameters, a 3 rotation matrix, and a translation vector. The camera projection matrix can be used to associate points in a camera's image space with locations in 3D world space. Camera resectioning is often used in the application of stereo vision, where the camera projection matrices of two cameras are used to calculate the 3D world coordinates of a point viewed by both cameras. Some people call this camera calibration, but many restrict the term camera calibration for the estimation of internal or intrinsic parameters only. Algorithms. There are many different approaches to calculate the intrinsic and extrinsic parameters for a specific camera setup. Direct linear transformation method, Zhang's a flexible new technique for camera calibration. Tsai algorithm. Zhang's method Zhang's camera calibration method employs abstract concepts like the image of the absolute conic and circular points. Derivation. Assume we have a homography that maps points on a probe plane to points on the image. The circular points lie on both our probe plane and on the absolute conic. Lying on of course means they are also projected onto the image of the absolute conic, thus and. The circular points project as. We can actually ignore while substituting our new expression for as follows. Size algorithm it is a two-stage algorithm, calculating the pose in first stage. In second stage it computes the focal length, distortion coefficients and the z-axis translation. Selby's method Selby's camera calibration method addresses the auto-calibration of X-ray camera systems. X-ray camera systems, consisting of the X-ray generating tube and a solid-state detector, can be modeled as pinhole camera systems, comprising 9 intrinsic and extrinsic camera parameters. Intensity-based registration based on an arbitrary X-ray image and a reference model can then be used to determine the relative camera parameters without the need of a special calibration body or any ground truth data. See also, augmented reality, augmented virtuality, mixed reality, pinhole camera model. References: Richard Hartley and Andrew Zisserman. Multiple view geometry in computer vision. Cambridge University Press, pages 155-157. ISBN 0-521-54051-8. Zhejiang, a flexible new technique for camera calibration, IEEE Transactions on Pattern Analysis and Machine Intelligence, Volume 22, Number 11, pages 1330-1334, 2000, P. Storm and S. Maybank. On plane-based camera calibration, a general algorithm, singularities, applications, in Proceedings of the IEEE Conference on Computer Vision and Pattern Recognition, pages 432-437, Fort Collins, Colorado, USA, June 1999, Roger White Sci, A Versatile Camera Calibration for High-Accuracy 3D Machine Vision Metrology Using Off-the-Shelf TV Cameras and Lenses, IEEE. Journal of Robotics and Automation, Vol. RA3, No. 4, August, 1987, Boris Peter Selby al., Patient Positioning with X-ray Detector Self-Calibration for Image-Guided Therapy, Australasian Physical and Engineering Science and Medicine, Volume 34, No. 3, pages 391-400, 2011. External links: Zhang's camera calibration and size calibration softwares on LGPL license, Zhang's camera calibration method with software, C++ camera calibration toolbox with source code, camera calibration toolbox for MATLAB, the DLR Calda and DLR Cal Lab camera calibration toolbox, camera calibration, augmented reality lecture at TU München, Germany, size approach, camera calibration, a 4-step camera calibration procedure with implicit image correction.